Okay, our third topic is how to graph radical equations. So this question is asking us to describe how the following equation shifted, give its domain and range, and then graph the function. Okay, so the first thing I want to do is I want to give you the standard form of your radical equations. So that's y equals a times the square root of x plus h minus k. So let's take some notes here. A is your vertical compression if it's between 0 and 1. It's a vertical stretch if A is greater than 1. And then it reflects over your x-axis when A is a negative. The negative itself is only doing the reflecting. After that, you determine, just looking at the number itself, ignore the negative, whether it's a vertical stretch or compression. Once we'd have that, the h, that is your horizontal shift. So x plus h is left h, x minus h is right h. It's always the opposite. And then lastly, your plus k here, plus k, sorry about that. Your plus k is your vertical, your up and down. So if it's plus k, you're going to go up k. If it's minus k, you're going to go down k. So let's look at this problem and decide, how did it shift? The first thing I notice is this 3 here. 3 is greater than 1, so it's a vertical stretch by 3. The next thing I'm noticing, this plus 2, that's your h, so always the opposite, so left 2 units. The next thing I'm noticing is this minus 1, so that's down 1 unit. H and k also give your domain and range, and we'll also look at that when we talk about the graph. So your domain, so it's x such that how many units did you move? Left 2, that means you are greater than or equal to 2. And we'll talk about that more when we look at the graph. Your range, let's get another color going here. Those are your y values. Your y values are coming from your k value. So y is greater than or equal to that down 1, that negative 1 unit. Okay, so if we're graphing here, so I'm going to write my equation over here so I can reference it. So y equals 3 square root of x plus 2, not h, plus 2, minus 1. Okay, so when we do some graphing here, the first thing I want to show you is your parent function that you looked at your notes. Our parent function, we call it a parent function for a very specific reason, because all your radical functions move based off of that original one. So knowing what that looks like is very important. So your parent function starts at 0, 0, then it hits 1, 1, and then it goes to the point 4, 2. So it's going to look something like this. Make that point a little bit bigger. So we learned that our graph went left 2 units. So it went left 2, and then it went down 1 unit. So let's mark that in. So left 2, and then down 1. So now that 0, 0 point moved to this red point. From here, the vertical stretch means that you're stretching it upwards. It's getting bigger, so it's going to look something like that. It's going to go up at a much quicker pace. The last thing we talked about that I want to show you on the graph is the domain. So if you look, your point is right here, and it's using all of these x values to the right. So it's starting at -3, it's equaling -3, and it's going to the right. So the domain, when you're going to the right, has to be greater than or equal to -3. So that's how I'm getting the domain from the left side here. The range, that's your y values like we said. So the range is starting here, again, at that y value of -1, and it's going upwards this direction, up the y-axis, because your graph is going up, right? So the range has to be y is greater than or equal to -1. And that's it for this video. Off to the next one.